Example 7, one side of a rectangular opening for a heating pipe is 3 inches longer than the other side. The total cross-sectional area is 70 square inches. Find the dimension of the cross-section. They do a lot of cross-sections in this part of the book. When you see a cross-sectional area or a cross-section, you've all seen heating pipe, right? Those, like if you're down in somebody's basement, you look up in the ceiling, you got those steel, rectangular pipes, right? That's what a heating pipe looks like. So if you consider this, don't draw the three-dimensional, but I'm just going to, for the sake of you being able to see it. So imagine we have this here, and it extends off like that. So, so we got something along those lines there. Okay, so there's our heating pipe. When they say cross-section, they mean if you were to take that pipe and slice it, and just look at the end of it. Okay, so it says the rectangular opening. They're asking us to look at a rectangle. So the first thing I would recommend in problems involving geometry, which a lot of these problems involve geometry, is if there's a figure mentioned, a shape mentioned, a triangle, rectangle, circle, whatever, draw a picture of that object and identify things you know in it that will help you to set things up. So that's what the opening looks like. If I were to just slice the pipe and look at the end, it'd be just a rectangle, right? It tells us the one side is 3 inches longer than the other side, and the way I've got this drawn, this is the longer side, right? So if one side, this side is 3 inches longer than the other side, that side, I give this side some name x. This side's 3 inches longer, so that'll be x plus 3. Very important algebraic step there, using the same variable to represent two different things. There's a relationship between the two sides. Use that relationship, use x for both, rather than using, let's say, length and width. Right? So using the same letter x to represent both is much more powerful than saying x, y, or length, width, or something like that. Okay. It says the total cross-sectional area is 70 square inches. How do you find the area of a rectangle? Length times width, right? So the length x plus 3, bless you, times the width x should equal the area 70. So it would be x times x plus 3 equals 70. Again, they didn't give me the equation. I know how to find the area of a rectangle. I drew the rectangle. I identified the sides using variables. I created an algebraic sentence to represent their area in algebraic form equal to the area they gave me. Now, if I simplify this, this happens quite often in these problems too, where there's a distributive property happening. So x squared plus 3x. As long as this object's addition or subtraction of more than one thing, you're going to distribute. If it was just x times 3, that's 3x squared. But if it's x times x plus 3, it's x times x squared, x times 3 plus 3x. So again, if this is a plus or a minus, you have to distribute. Okay, and then we're at x squared plus 3x equals 70. So now we're in a simplified quadratic equation structure. I see a quadratic term x squared. I see a linear term 3x. So I know the quadratic formula is going to be used. And if I'm using the quadratic formula, before I can do that, I have to get everything equals 0. So x squared plus 3x minus 70 equals 0. Again, quadratic formula requires that structure. And if I write down my answer structure, x equals something plus or minus the square root of something over something. I need to know what those three numbers are. Same stuff we've been doing here for a few days. So a is equal to positive 1, b is equal to positive 3, c is equal to negative 70. A few of you have been struggling with the whole numbers, negative numbers and positive numbers. Make sure that you're paying close attention to detail on your signs. That's positive 1, that's positive 3, that's negative 70. So if b is positive 3 minus b is negative 3. A is positive 1, 2 times a is going to be positive 2. B squared minus 4ac. B squared is 3 squared, which is 9, minus 4 times 1 times negative 70. This is negative 70. So when I multiply my numbers here, minus minus makes plus. 4 times 1 times 70 is 280, which is 289. So again, evaluate those three things to put them into the structure here. Let's slide this over a little bit. Maybe I'll slide it over. Pick the right tool here. So, what goes in the top left slot is negative b, which is negative 3. What goes on the bottom is 2a, which is 2. What goes under the radical is b squared minus 4ac, which is 289. If you get a calculator out and punch in square root of 289, it's going to say 17. Even if it didn't come out nice and pretty, give me a decimal approximation. It doesn't matter as far as that's concerned. And then, so the answer is going to be something over 2 and something over 2. To get the somethings, we're going to do negative 3 plus 17 and negative 3 minus 17. So negative 3 plus 17 is 14. Negative 3 minus 17 is negative 20. So the answers for x are either positive 7 or negative 10. What does x represent in this picture?
1.
Length of the side. So which answer makes sense?
Positive.
The positive 7. So we throw out the negative answer because negative answers don't make sense for the lengths. It says find the dimensions of the cross section. If x equals 7, how big is x plus 3? 10. So the correct answer to the problem is 7 inches by 10 inches. Okay. And think about the two criteria here, what they told us, right? It says one side is 3 inches longer than the other side, right? 10 is 3 bigger than 7. And the area of this is supposed to be 70. 7 times 10 is 70. So both criteria are met with those answers. So that'd be the proper dimensions.